Welcome to Module 4 in this course on network cabling systems. Following the AT&T divestiture of 1984, the end user became responsible for all premises cabling for voice and data. Advancements in voice and data communications and the convergence of voice and data communications led to increasingly complex interactive systems owned and maintained by the end user. In July of 1991, the first version of the telecommunications standard was published as ANSI EIA-TIA 568. The 568 standard was revised to 568A in 1995, and in 2001, 568B1, which is the basic or general part of the standard, B2 for copper cabling, and B3 for optical fiber cabling were published. Along with this mother standard, other standards evolved over the next 15 or 20-year period. The TIA-EIA structured cabling standards define how to design, build, and manage a cabling system that is structured, meaning that the system is designed in blocks that have very specific performance characteristics. The blocks are integrated into a hierarchical manner or fashion to create a unified communications system. Once again, I'm Ted Chandler, your CIS instructor for this online course. In this module, you will learn to first discuss the importance and features of standards-based structured cabling systems. You'll also be able to describe the industry standards associations and recognize and discuss the TIA-EIA telecommunications cabling standards, including 568B, 569A, 570A, 606A, and 607B. Now, cabling systems must be installed in accordance with the cabling standards to ensure safety, that parts work together to deliver expected results, and work without causing problems for all other systems. Codes like the National Electrical Code and local codes must be followed to ensure safety. But standards, or telecommunication standards, are voluntary guidelines that should be followed to ensure safety of performance and interoperability. Another area, regulatory codes or rules must be followed to ensure that the public network is not compromised. Now, an ideal standards-based structured cabling system must address the following design criteria. First, it must meet all regulatory codes, such as the local and national fire safety codes. It should follow TIA-EIA cabling standards. It should exhibit flexibility in its design to allow integration of a wide variety of voice and data components, active components. It should exhibit modularity in its design, allowing active equipment to be moved and repatched without recabling. That's called moves, adds, and changes. And finally, an ideal structured cabling system should allow for future upgrades, also called moves, adds, and changes. Again, let's review the features of a standards-based structured premises cabling system. First, it is open or generic in its cabling design. That is, that it's open to all manufacturers, not just one. It should be industry-based with a single solution. It supports all types of communication systems. It is designed for both a single building with multiple floors on it or several contiguous buildings, such as a campus. It is vendor and application independent. It supports multiple applications and independency. It supports most local area network technologies, supports multiple logical topologies. It supports networking device interoperability, and supports future application technologies and networking devices for the next 10 or 15 years. So let's review the primary telecommunications standard organizations that you should know. First is ISO, which is the International Standards Organization, and they're based in Geneva, Switzerland. ANSI, or the American National Standards Institute, is here in the United States, and they're responsible for actually publishing all standards, whether it's telecommunication or mechanical or electrical standards. TIA, which is the Telecommunication Industry Association, is basically responsible for writing the American telecommunication cabling standards. EIA is the Electronic Industry Alliance. CSA is the Canadian Standards Association. IEC is the International Electrotechnical Commission, and they're located in Europe. CNLAC, which is the European Committee for Electrotechnical Standardization, and finally the Australian New Zealand standards. So these represent the standards organizations that are responsible for the telecommunication standards worldwide. The telecommunication standard that you should know are, first, the mother of all the standards, which is 568B, Commercial Building Telecommunications Cabling Standards, and this is in three parts. B.1, which is Commercial Building Telecommunication Cabling Standard General Requirements. B2, which is the Balanced Twisted Pair Cabling Components, or the copper cabling part of the standard. And B3 is the Optical Fiber Cabling Component Standard. The next standard is 569A, and that's the Commercial Building Standard for Telecommunications Pathways and Spaces. 570A is the Residential and Small Commercial Building Telecommunications Cabling Standard. 606 is the Administration Standard for Telecommunications Infrastructure for Commercial Buildings. And 607 is the Commercial Building Grounding and Bonding Requirements for Telecommunications. I'll describe each of these standards in more detail in the next few slides and in future modules. Now, the purpose of the 568B Commercial Building Telecommunications Cabling Standard, which is called the Mother Standard, is to provide the minimum requirements for telecommunications cabling within a commercial building or campus environment. This standard is published in a three-part document. First, B1 discusses general requirements. It provides information in regards to planning, installing, and verifying structured cabling systems in commercial buildings. It also establishes performance parameters for cabling systems such as channels and permanent links. One of the major changes in this document is that it only recognizes Category 5E or higher category cabling for the second data outlet. B2 discusses balanced twisted pair cabling components. This standard specifies cabling components and transmission requirements for a cabling system. B3 discusses optical fiber cabling components. This standard specifies components and transmission requirements for optical fiber cabling systems. The TIA 568B standard specifies subsystems of structured cabling systems, recognized media, cabling connecting hardware, that the cabling system must have a star topology. It recognizes and specifies cabling distances, installation practices, user interface, and link and channel performances. Now, the primary focus of the 569A Commercial Building Standard for Telecommunication Pathways and Spaces focuses on providing design specification and guidance for all building facilities related to telecommunications cabling systems and components. This standard identifies and addresses 6 prominent components of the building infrastructure: the horizontal backbone, telecommunication room, work area, equipment room, and main terminal spaces. Actually, there are 7, including the entrance facility. Now, this standard includes small office, high-rise, campus, and gated communities. Similar to 568B, commercial building standard requirements, it requires that a star topology for a multimedia distribution panel be used, and it should have a 90-meter link and a 100-meter channel, that it uses 100-ohm UTP twisted pair cabling, copper cabling, and you can also use a 62.5 125 micron or 50 125 micron multimode optical fiber, and that you use an RG6 and RG11 type coax cabling. Modern buildings require an effective telecommunication infrastructure to support the wide variety of services that rely on electronic transport of information. Administration includes basic documentation and timely updating of drawings, labels, and records. Administration should be synergetic with voice and data and video telecommunications, as well as with building signal systems, including security, audio, alarms, and energy management. Administration can be accomplished with paper records, but in today's increasingly complex telecommunication environment, effective administration is enhanced by the use of computer-based systems. Each space, pathway, cable termination point, and ground is assigned a unique identifier number that can be simply encoded to provide supplemental information. .607 standard specifies a uniform telecommunication grounding and bonding infrastructure that shall be followed within commercial buildings. These systems require a reliable electrical ground reference potential. Grounding by attachment to the nearest piece of iron pipe is no longer satisfactory to provide ground reference for sophisticated active electronics. Solid copper grounding bus bars are installed with insulated standoffs in entrance facilities and equipment rooms, as well as each telecommunication room. Each bus bar is drilled with rows of holes in accordance with NEMA standards for attachment of bolted compression fittings. Telecommunications equipments, frames, cabinets, and voltage protectors are typically grounded to these bus bars. In summary, we have discussed in this module the importance and features of standards-based structured cabling systems. We have described the industry standards associations and recognized and discussed the telecommunications cabling standards, which include 568B, called the mother of all standards, and it's the commercial building telecommunications cabling standard. 569A is the commercial building standard for telecommunications pathways and spaces. 570, which is the residential and small commercial building telecommunication cabling standard. 606, which is the administration standard for telecommunication infrastructure. And 607, which is the commercial building grounding and bonding. This completes Module 4 on the telecommunications industry organization and standards. Please take your exam on Module 4 or Quiz 4, and I'll see you in Module 5.